All right, I think we are live. Hello and welcome everyone. Thank you for joining. I hope everyone's having a great day so far today. This is a webinar for AFT Arrow 9 new features. My name is Kyle Clark. I am an applications engineer here at Applied Flow Technology. This is my very first time to host a webinar, so I just want to say thank you for taking the time to tune in. I hope you get something useful and informative out of today's webinar. I'd like to go over just a few things in the agenda for this webinar so you have an idea of what to expect and what we're going to be talking about today. So some of the things we're going to be talking about today is going to be the new help files, our new help file system, some new pipe features, the zero length connector, the special condition toggle that's new on the toolbar, custom unit names, analysis setup, which is a big new feature. I'm excited to show you that one. A couple new equations of state that we've added, the new AFT Arrow 9 XTS, or the extended time simulation add-on module. This is another big new feature that I'm very excited to show you. Some improved organization on the warnings tabs. We did an overhaul of the databases, which are now called libraries. A couple smaller features, such as the same as parent feature from the workspace, some being able to search notes from select special, silent batch run warnings and design alerts, and special condition state changes listed in solution progress. So those are going to be the things that we're going to be talking about and going over today. There's a lot of new features, some big, some little, but hopefully all of them will be useful to you in some way or another. So let's go ahead and dive in. The first new feature I want to talk about is actually not even in the software itself, and it's the new help files. We have completely changed to a new online platform for our help files. Before Arrow 9, you had to use the clunky CHM files to get the help that you were looking for. These were typically installed as part of the Arrow 9 installation. This was a somewhat outdated medium to get you the help information that you were looking for. And so now all the help files can be found online. They're easy to search. The formatting, it just looks spectacular. I know what you're thinking. Well, how do I get there? A couple different ways. Easiest way, straight from the webpage, www.aft.com. We added this nice documentation button at the very top. You just click that and it will take you to the AFT documentation portal. As you can see, we have all of our applications here. We can jump into the AFT Arrow help site just by clicking the big button. And this is the AFT Arrow product help file. The kind of the structure is very similar to what we had in the CHM files. We have the menu on the left-hand side. Here you can go through and find the specific topic that you're looking for. You know, if you want to go through and read about some of the new features we're going to be talking about today, you can read the topics about what's new in version 9. We have topics about pipes, about different junctions. You know, you can even go in, you can look at stuff for theory. You know, if you want to understand kind of the internal workings of Arrow, some of the engineering assumptions we've made. We also have add-on modules, so GSC, or the goal seeking control, automated network size, extended time simulation, which is the new one we're going to be talking about today. I mean, any of the help information that that you might be looking for to try to understand, hey, what is Arrow doing? What do these different parameters mean? Check out these new help files that you can find online. Very helpful, very useful. If you're not sure where to find maybe the particular topic that you're looking for, you can use this the search bar at the top to be able to search and find what you're looking for within the help files. We also added in the examples. These have always been part of the software, but we made it a little bit easier to find here within the help files itself. So these help files are like walkthrough examples where we show you how to build a model from scratch. Each example is kind of pointing out or highlighting a particular feature or teaching you how to use a specific part of Arrow. So you can go through these examples. I'll just open one up real quick. So you can see we have these problem statements, and very easy to follow step-by-step instructions. We have plenty of screenshots to show you how to build those models. Maybe you don't have time to build a model and you just want to run the completed one. We've included that for you. Like I said, this has always been a thing that we've had, but now it's just a lot easier to find here within the help files themselves, down here at the bottom with examples. We also have verifications where we have compared the results that Arrow generates to academic sources and other things to show, hey, you know, we're calculating things the right way. Arrow is performing these calculations correctly. You can go through, explore those, and look at those. So let's see. Another way to get to these help files is from within Arrow itself. So of course, this help menu button at the top, we have open help. It will launch the browser for you and take you right to that landing page that I was just showing you previously. This has always been there, but obviously the help file platform is new. And another helpful way to get to the help files is this help button. This is in almost every window, every properties window, junction properties, pipe properties. There's this help button right here on the right below the OK and cancel button. So let's say you're going in, you're defining a valve in your model, you're filling out all this information. You get down to the bottom and you see this CDA, forced sonic choking optional, and you think to yourself, what is this? I have no idea what this is. Click this help button. It will take you to the help site so you can read, you can understand, okay, here, CDA for sonic choking, get the information that you need. Maybe there's other questions you have. Scroll down, we have a related topic section to help jump you to another section to help you get the information you need. We also include some of the related examples as well as blogs. If you're not aware, we post typically 1 or 2 blogs every month about you know, maybe highlighting a new feature or kind of going in depth about a particular topic in AFT applications. And so we have those linked if you want to read more about those. So there's a lot of ways you can get to these help files. There's a lot of useful information in them. All right, so new help files. They're spectacular. They're very helpful. Check those out. Now let's dive into some of the new features within Arrow itself. The first one I want to talk about is the zero length connector. I'm sure many of you have been in the process of building a model in Arrow, and you ran into a situation where you need to model one component, such as a compressor, right next to another component, such as a valve. So here's your compressor, here's your valve. You have these right next to each other. There's virtually no length of pipe between these two. From my experience, both as a user and as one who's been responding to support emails, what I've seen and what I've done myself is users will open up this pipe properties window. You know, we'll go in, we'll define this pipe, and they'll pull this number right here. Well, they'll just make this pipe length a very short length, 0.0001 feet long, to try to functionally simulate a lengthless pipe. Now, I would definitely not recommend doing this. This is not only not an accurate representation of the actual system that you may be modeling, it's bad modeling practice. Stunts like this, it can lead to convergence issues, it can lead to long run times, problematic results. Nobody has time to deal with that stuff. So we saw that there is a need for functionality to have a pipe that is functionally zero in length, and so we added this zero length connector. You see right here next to the length, we've added this checkbox that says model as zero length connector. All you have to do is check that box and you'll see the length field disappears. And we now have a zero length connector. Let's see. So what this will do is by clicking this button, it will model this as if this compressor and this valve are immediately connected together, almost welded together. You don't have to enter in that very short length. You still have to define a pipe size, and I'll talk about that in a second, but this is a good way to go and model lengthless pipes. you've noticed that some of the other tabs that are typically in the pipe properties window have now gone away. So pipe fittings and losses is now gone. Design factors, heat transfer, all that is gone because it's irrelevant. And so we just completely take out those tabs. This is a completely lossless, frictionless pipe. It's just a connector between these two junctions. So you still have to define a pipe or pipe size, and let me show you why. So if I've defined this as just a 3-inch pipe and I say it's a 0-length connector, you may be aware that a lot of the junctions that use losses, particular loss models, they reference by default this upstream pipe size. So you'll see when I open this valve properties window, it uses the basis area from pipe 3, which is the pipe that I just set to be a 0-length connector. It uses that diameter to calculate the losses, such as the CV value, for this valve. By default, it's the upstream pipe, and so that's why you still need to put in a pipe size, but that doesn't affect anything within that pipe itself. It's just used as a reference for the downstream junction of the pipe to calculate the losses there. So 0-length connector. To summarize, this is a great new feature. No more 0.0001 foot long pipes. Use the 0-length connector instead. It will make your models run smoother and faster because you're taking out that unrealistic pipe length. All right, so let's move on to another new feature. This one is a little bit smaller, but it's one that, as I've been using Arrow 9, I've really come to appreciate it and I really like it. That's the special condition toggle. So while we're in this valve properties window, I want to discuss the existing feature of special conditions, which has always been there, but explain what that is to kind of introduce this new feature. So in the valve properties window, in a lot of junction windows and pipe properties window, there's this optional tab. If you're unaware, on this optional tab, there's this area called special conditions. This is a way that you can, quote unquote, turn off that valve or turn off parts of the model. Right now, by default, this junction is set to none, meaning the valve is open, everything's going to be just modeled normally. By selecting closed, it will model this valve as if it's closed, meaning no flow will be allowed to pass through it. If you see when I click OK, after closing that valve, Arrow will make these pipes dotted, meaning that this whole pipe path is now closed. There's going to be no flow because I have this valve closed. Now, the more indirect way of doing this is, of course, opening the valve properties window, going to the optional tab and clicking this close button. The other way of doing it is selecting that valve, and then there's this red circle with a slash mark on the toolbar. That is the special conditions from the toolbar. Before Arrow 9, you could just click this button and it would toggle off or on whatever junction or pipe you had selected on the workspace. And this was great. This was very useful. You don't have to open up the pipe properties and then go to the optional tab to do this. But it presented a little bit of some confusion when you had a junction that had maybe more than 2 special conditions. And let me show you. Here in the compressor properties window, if I go to the optional tab to see the special conditions area, we'll see that I now have 3 special conditions for a compressor. I have none, which is just normal operation for the compressor. I have compressor off, no flow, and as the name describes, this will model the compressor as if the compressor's off. You're not going to see any pressure increase across that junction, but it will be closed. No flow will even be allowed to pass through that. Similar to having the closed valve, no flow will be allowed to pass through. That's the one special condition. The third special condition is compressor off with flow through. Similarly, the compressor is not going to be operating. You're not going to see pressure increase across that junction, but flow will be allowed to go through it. And you just won't see that pressure rise through it. So you'll see if I select this option and click OK, the pipes are not dotted, meaning that flow will be allowed to pass through we see this X next to J3, meaning the compressor is not going to be operating. It's just going to be sitting there open, allowing flow to pass through. So with the special condition toggle before Arrow 9, you just had to select this special conditions button, and it was unclear which special condition is being applied. Is it applying the compressor off no flow, or is it applying the compressor off with flow? It was unclear. So with Arrow 9, we added this drop-down button so you can select specifically which special condition that you want to apply. So you can just go in straight from the workspace. You don't have to open the properties window and say compressor off no flow, and it applies that to the compressor. Similarly, we have the same options for valve. Of course, valve only has none or closed. And so these are the special conditions you can toggle straight from the workspace with this new drop down. Now, you might be wondering, well, why would I put a model in my, or put a valve in my model if I'm just going to turn it off? For a couple of different reasons. You might be trying to model different system configurations where you have certain parts of the model turned off. Maybe you're trying to troubleshoot a particular area, so you're shutting a valve, or you're setting the compressor to only operate off with flow through to try to maybe troubleshoot different things. The special conditions feature is a very helpful way to turn off parts of your model, so you don't have to just go in and delete a bunch of pipes and junctions to try to kind of model different configurations. You can just turn it off. Arrow will treat that part of the model as just as off. It won't calculate the flow or the pressure into it because there's going to be no flow into it. And so that was it's a very useful feature to use special conditions. So Arrow 9, specify exactly what special conditions that you want for that junction using that new drop-down feature direct from the toolbar for setting the special conditions for your pipes and junctions. All right, let's talk about one more smaller, more minor improvement, new feature before we get into some of the bigger ones. So this one is custom unit names. So you can get to this new feature from the tools menu and then user options. So by going here, we've added this new section under unit system called edit custom unit names. So what this is you can go in and you no longer have to use the default unit names that AFT provides. So let me go to an easy one like length. So length, I know for a lot of users it maybe bothered them that maybe we spelled out meters, or we didn't abbreviate feet, or how we abbreviated kilometers, and they wanted to change that. They wanted in their output that they're presenting, they wanted to show maybe the units that they're more comfortable with, the unit abbreviations that they understand better. And so we've added in this ability to customize the unit names that are displayed. So for instance, I can go in here and I can say, well, I don't want feet, I just want FT. Maybe I don't want km for kilometers, I want to actually spell out kilometers. And for meters, I don't want meters, I just want M. You can go in, specify the unit names that you want to be that's going to show up in the properties window, in the output, everywhere. You specify that here in this edit custom unit names, and then click save and close. And let me show you this in action. I'm just going to open up the pipe properties window, and you see here in the length, I can see these new custom unit names that I just entered. Feet just abbreviated as FT, spelling out kilometers in full, and then just using M for meters. We can see our custom unit names are being used right here. You'll also see these unit names used in the output as well. So it's nice that we have a little bit more control, that you now have a little bit more control over what are the unit names that are going to be shown. This feature uses UTF-8 encoding, meaning that you can use superscript. So for acceleration, if you want to use feet per second squared with that 2 as a superscript, you can superscript that 2. Just if that's something that you prefer, if you don't like the 2 just being normal size, you have a lot more flexibility to be able to customize that. Now let's say you go through and you set all your custom unit names to exactly the way that you want to. You take a lot of time and you want to send this to a friend or to a coworker so they can use that in their model. we've added the ability to save the units that you've specified to a CSV. So you can save all those units, send it to a coworker. They can use the load units from CSV to load it into their model. So that way they can get those same units that you're comparing, you're looking at the same set of units together. Maybe you want to set the units to have one maybe unit name for one particular project that you're working on, and maybe you're working on another project that has a different abbreviations. You can now pull in, you can save, you can load units based on the project that you're working for. It's not something that you have to use universally. So use that save and load buttons to be able to customize when you're using it, to be able to send it to friends, and so on. All right, let's see. Okay, I think that covers that new feature. Let's get into some of the bigger new features. Now this one, analysis setup. This by far is one of the most, is a major, it's one that I have just come to love with Arrow 9. As I've been working in Arrow 9 and I'll switch back and I'll start working in Arrow 8, I really miss this feature. So it's a new feature, but I can promise you, you're gonna love it. You know, right when you start working on it, and then you're going to go back to other versions that say, man, I really miss analysis setup. It's a great new tool. So you may have noticed up here on the top of the toolbar, we have this analysis setup button. What this is we have combined multiple different windows together into a single consolidated window called analysis setup. So solution properties, system properties, let's see, cost settings, all of this has been put into one window where you can define almost every part of your model just from one single window. There's no more going in and opening and setting your solution control, you know, saving and closing that window, going in, open your goal seeking control to set your variables and goals, and jumping between all these different windows. Now you can do it all from one window. I have just come to love this new feature. So let me just give you a little bit of the background and some of the terminology that's used in analysis setup. You'll see we have this menu on the left. Each of these titles that you see are called groups. So we have the modules group, the fluid properties group, pipes and junctions group, and so on. These are all groups of analysis setup. Each group you can expand to see the items in that group. So in the steady solution control group, we have the solution method item, the tolerance item, iterations item, and so on. Within each item, you can select that item to open that item's panel. So I just clicked the solution method item, and now I've opened the solution method panel. Here, this is basically the same as the solution control window that was previously in Arrow 8. Now it's all in one place. So you can go in, set your solution method, maybe go over to the tolerance panel, you know, adjust the tolerance if you need to, and then you can go right away into maybe the modules or the fluid panel and define your fluid. It's great because you can quickly go from one panel to the other to define basically every part of your model, with the exception of the pipes and junctions that you actually are placing on the workspace. So you build your model on the workspace, and then basically everything else is done within the analysis setup window. Also, this analysis setup has come to replace the checklist. So before, if you remember, there was a checklist that you could open up to see, hey, what's left in my model that I need to define before I can hit that run button to get my results. Now, the analysis setup provides that checklist, but it also provides you the way to define those items. So you'll see this red exclamation point next to the fluid properties group is telling me, hey, I need to define a fluid before I can run my model. I also have some pipes and junctions on my workspace that are still undefined. This green check mark means that that group is defined. No more user input is required. It's sufficient to run the model. So I'll only go into the fluid panel, and here it's because I don't have a fluid defined. I can define my fluid, and once I add in, let's say I add an air to be my fluid that I'm using, you'll see that the group and the item turn to that green check mark, meaning, hey, I've provided the necessary input for the fluid properties group to be defined. I can now then move on to the next part of my model. While I'm here in the fluid panel, I want to talk about another new feature, and that's the new equations of state. So this may look familiar to you if you're a heavy Arrow 8 user. This is the old system properties window, but now in the fluid panel of analysis setup, you can select your fluid the same way. We have the same fluids, the fluid databases or libraries available, ASME, Steam, Chempac, RefProp. These are unchanged, but we did add for AFT standard fluids the equations of state. If you've ever played with this, you know that once you select your fluid, your AFT standard fluid, you can then go down and select the equation of state. By default, we use the Redlich-Kwong equation of state, but we've added two new ones. We've added the SOV Redlich-Kwong or SRK, as well as the Peng-Robinson equation of state. If you're unfamiliar with these, SRK is particularly useful with when you're modeling non-polar fluids, and it's also generally better than Redlich-Kwong. For Peng-Robinson, it's a pretty near tie between Peng-Robinson and SRK. They both give very accurate fluid properties. I believe Peng-Robinson was specifically developed for natural gas systems, and it gives slightly better performance around critical conditions. So if you're kind of operating to that point, you may consider using Peng-Robinson, but at the end of the day, Peng-Robinson and SRK are pretty much a tie, but both of them much better. They give more accurate properties compared to Redlich-Kwong. So I'm very excited about these two new equations of state. Those are available for the AFT standard fluids, and all you have to do to select those is after adding your fluid to the model, you just have to use that drop down, select your equation of state. So to summarize analysis setup, it's this new consolidated window where you can define virtually everything apart from placing pipes and junctions on the workspace, all in one place. Now, you may have noticed when I went over to the modules panel, well, yes, let's see, we'll apply that. This is where you can activate your modules. You may have noticed this new area, the XTS, the Extended Time Simulation module. Now, this is a huge new feature. This is an optional feature. It's not part of base AFT Arrow 9. It's an add-on module that requires an extra license to use. If you have used Fathom, there's an XTS module as part of Fathom. And what this does is it allows slow transients to be modeled. If you are, say, pressurizing a tank, or you have a control valve that's opening slowly or closing slowly, or you have a compressor, a slow compressor transient, you can use the XTS module to model those slow transients within your piping system. Now I use the term slow transient because XTS, it uses a series of steady state snapshots or pseudo steady state snapshots to calculate the output based on the user defined transient. So it will run a steady state run just like Arrow normally does. It will look at the next time step, which may be a minute. It will make the necessary adjustments to maybe how much the valve is closed. Maybe you're pressurizing a tank. What's the new pressure of the tank? And then it will take, in the next time step, run another steady state analysis, and then continue to do that for every time step during your simulation. Important to note, pressure waves are not tracked through the system using Arrow XTS because pressure waves are characteristic of what we call fast transients. So if this is what you're interested in, if you want to see, hey, how is my pressure, how is my temperature going to change in my compressed gas system when I say slam a valve shut, you should check out AFT Extreme. AFT Extreme was developed. It's a new application that we released last year. It may be a more suitable option for you if that's the type of transients that you are trying to model. As far as Arrow XTS is concerned, we're looking at slow transients. Let me show you and demonstrate a little bit of the Arrow XTS in action. This is actually one of the example models that I was talking about earlier. Let's see, so here we have a very simple system. Let's see, I just want to walk through this system real quick and then talk about how to define a transient and what Arrow is doing. So I'm going to open up this, this properties tab as I'm going through this model to kind of show you what we're looking at, just to give you an overview of the system so it kind of makes sense of what's going on. You can see at the beginning of my system, I have an assigned pressure junction. Let me just pull that down. Okay, so we're starting, our fluid is air. We have this assigned pressure junction. It's set to 0 psig at 70 degrees Fahrenheit. So the air is coming in at this assigned pressure. We go into a 3-foot, or sorry, not 3 foot, it's a 20-foot pipe, but 3-inch diameter pipe before it goes into this compressor. This compressor is in the sizing feature, is using the sizing feature, where essentially you just specify the flow rate, and then Arrow will calculate the head rise or the pressure rise necessary in order to get that flow rate that you've specified. So I just have a positive displacement compressor with a fixed flow rate of 100 standard cubic feet per minute. It's going to, and there's a transient on here that I'm going to talk about in a second for the compressor. We're going to discharge from the compressor into another 3-inch pipe, go into a heat exchanger that's just using a very simple resistance curve loss. And I believe we have some thermal data input. We have a controlled outlet temperature of 85 degrees. After the heat exchanger, we're going into another 3-inch pipe and into a valve that's specified with a CV of 50 and an XT of 0.7. And then it's going to go into a tank. This is a 500-gallon tank that's initially at 0 pounds and 70 degrees Fahrenheit. All the elevations for all these junctions are 0 feet, so it's just a horizontal system. But what we want to see is what's going to happen, and what we're using Arrow XTS for is, we want to look at how is this tank pressure going to change as the compressor maybe starts to slow down. What's going to be the final pressure of this tank as the compressor slows down and ultimately stops? So let's open up this compressor and look at the transient. You may have noticed in this compressor properties window, we have this new tab that only appears when Arrow XTS is on. And in this transient tab, we can define the transient event that's going to be applied to this compressor. So here, what we have specified is we have a single event that's going to initiate the transient. We've set it to whenever the static pressure at pipe P4 outlet, so that's going to be right here at the outlet of P4 going into our finite tank, when the pressure at this pipe outlet reaches 125 pounds, then it's going to start applying the transient data. If you've used AFT Impulse a lot, you should be very familiar with this transient tab because you use this a lot in Impulse. But if you're not as familiar, if you've never used Fathom XTS or Arrow XTS, then this is probably going to be new for you. Once this single event is triggered, that the pressure in pipe P4 reaches 125 pounds, we begin this transient event. So what this says is at time 0, I'm going to have my mass flow rate of 100 standard cubic feet per minute, and then it's going to linearly decrease over the course of 30 seconds to 0 standard cubic feet per minute. To visually see what this transient is, you can click this show graph button, and it will show you that profile of what the transient data is going to be applied to your compressor. You can see we're starting out at 100 and going down to 0 standard cubic feet per minute over the course of 30 seconds. And this will only begin once the initiation event has been triggered. So I've gone ahead and I have run this model to get the output. And let's look at the output to kind of show you some of the cool things that Arrow XTS can do. You'll see I go to the output, and you may have noticed we're on the warnings tab. There's a caution. We have changed the formatting of the warnings tab, and this is a new feature with Arrow 9. We've improved the organization and added some color coding to this warnings tab. The warnings tab has always been there. It's not exclusive to Arrow 9, and this color coding is not exclusive to using the XTS module. But we've better formatted this to make it easier to kind of read, easier to understand what warnings that you're seeing in your model. The color coding, if we had critical warnings or warnings here in our in our model, those would appear in red to say, hey, these are important. You need to take a look at these. Cautions are going to be displayed in orange. Also, you can collapse these. So maybe you say, okay, I've already looked at my cautions. I already know what that is. I want to collapse it. I don't want to see it anymore. You can just collapse that caution area. You can do the same thing with the warnings or critical warnings just to make sure that this is staying organized. We've also improved some of the wording of some of these just to make it a little bit clearer, to make sure you, the user, are understanding what warning, what caution, what is this trying to communicate to you about the model. We've also separated out the design alerts. So those will appear in another tab separate from the warnings tab, and we'll display all of these similarly, where we have this color coordinating in a separate tab, so you don't see these at the same time that you're trying to maybe diagnose issues because of warnings or critical warnings, anything like that. So those are separate. So those are two new features that, reformatting of those two tabs. Let's dive back into Arrow XTS just for a moment to talk about some of the cool things that you can do within the output window with Arrow XTS on. So you'll see there are these new tabs in the pipe section as well as the junction section of the output window. We have this transient tab. We can click on this tab and we see the pipes and the transient data for each pipe. So this is essentially the output at each time step. So time step 0 is the very beginning of the transient, and then this number in parentheses is each time step that Arrow is taking. And we can see all of the output parameters and the output that Arrow has calculated at each individual time step, just by and for every pipe, for each kind of parameter that you have in the output. Now, this may be sometimes not very helpful because it's just a bunch of numbers. It's just a wall of numbers, a bunch of columns. There must be an easy way to graphically see what's happened. You're right. I want to show you the quick graph feature. So if you just right click on one of these properties, you can create a quick graph. You don't have to go to the graph results window and generate a complicated graph that you'll then lose later because you didn't save. Don't even worry about that. You straight from the output window, right click on that property and click quick graph, and you can immediately see the quick graph of whatever output parameter that you're interested in. So here I clicked the static pressure at the outlet of pipe 4. That's what we see here. We see the static pressure at the outlet and PSIA on the y-axis. We see time on the x-axis. This is actually the triggering event for our transient. If you remember in the compressor would trigger, start slowing down once the pressure at the outlet of pipe 4 reaches 125 pounds. And that was PSIG. Granted, this is PSIA, but we can see once that pressure reaches that point, we can see how the compressor, we can see based on this curve that the compressor is slowly starting to turn down, and we can see what that final pressure is graphically here using this graph. Now, if maybe you want to look at the flow rate, you can do the same thing, mass flow rate, create a quick graph. We see the same thing. We see, okay, we have a constant mass flow rate. That triggering event happens right here around the 340 second mark, and we see it drop down to 0 as we would expect. This is a very useful way to quickly see what your output is looking like for a specific parameter without going in and dealing with trying to generate a bunch of graphs in the graph results window. So quick graphs, very helpful, very useful. Close out of that. Okay, so I think that just about covers Arrow XTS, at least for our purposes. It's a great new feature. It's a new add-on module that just came out with Arrow 9. If you have questions, please reach out to us. We're happy to answer or give you a demo of, or give you more information about Arrow XTS. It's great. Let's switch speeds a little bit and talk about libraries. So I'm going to go over into this model and talk about libraries. Now that might sound new to you. Libraries are just a new name that we have given to replace databases. Databases are, and now libraries, they're a powerful way that you can use to save junction input information to save custom fluids, custom pipe materials, insulation and fittings and losses. AFT Arrow, it provides a lot of really good fluids. It provides a lot of pipe materials, fittings and losses for you to use, but I mean, we can't cover all the fittings, all the fluids that are out there. So we've added in the capability for you to add in your own custom fluids. And databases, now libraries, are the way that you can save that to your model and also use it for other models or for other engineers to use in their models. So if you've used databases before, you're going to be familiar with a lot of this. I can tell you that the main functionality of libraries is virtually identical as databases. So if you know how databases work, don't worry. There's no major changes. If anything, we've improved the user interface to make it easier for you to understand, what databases, what libraries are being applied to your model. So before in Arrow 8, this menu item, it would say database. Now it says library because of the renaming. We can go in and open the library manager. So let's open that up. Now this is a new window. It replaces the database manager that was previously in Arrow 8. And this library manager is a great new way to be able to see what libraries are being applied to your model, what libraries are actually just available but not applied to the model. You can go in, look at the specific junction input information that you have defined, or edit your fluids and so on. There's a lot more capabilities in Library Manager that was not in Database Manager. So you can see right here in the library browser, I have all of my different pipe materials that are listed. I have my local user library. Let me just open that up to show you. I have a few junctions that I've just saved to kind of demonstrate a little bit of what's in here. I have a heat exchanger, a compressor, and what this is essentially, it's like having predefined or saved junction input information that you can then readily use for another model. So let's say you build a lot of models that have a compressor, and you have a particular compressor curve that you use over and over and over again in every model, and you're really tired of, for every model that you build, you have to go into the compressor, define the flow rate and the pressure, generate a curve fit, because you're basically doing the same one for every compressor, and you say, hey, I wish there was a way that I can just save this and I can just apply it to every new model that I'm building. Libraries are the way that you can do this. So you'll see I have this Kyle's custom compressor already saved in here. To see what this input information is for this compressor, I can right click edit content, and we'll open up the properties window for that compressor, and I can see everything that's being applied here. This one that I have saved, Kyle's custom compressor, is just a sizing compressor, centrifugal compressor that has a fixed flow rate of 100 cubic feet per second. Pretty standard, but it's one that I can quickly throw into a model if I'm trying to put a model together really quick, and I know what it is because I use it a lot. If you have, let's say you go through and you save a bunch of compressors or other junctions to a library, you might be wondering, well, how do I apply this saved library to a junction? Within the junction properties window, you'll see there is this library JCT or library junction drop-down menu. If I look at that drop-down menu, there's my Kyle's custom compressor. If I select that, it will use the input information that I have saved in my library and then just auto-populate everything in this compressor properties window, including other tabs, everything. It will just throw that in there. You can then click OK, everything's saved, and it will be used for that compressor. Maybe you make a few changes. You can go in and you can save it by selecting the library menu and then add junction to library to then save that junction input information into a library that you have. If you've used a lot of the cost functionality of Arrow or Fathom, you're probably aware of how these libraries work because you need an engineering library to apply a cost library to it to perform cost calculations, which if you're not aware, that's been a feature in Arrow for a while, not new to Arrow 9, but it's a helpful new feature to be able to do cost calculations. Also in this library manager, I just want to show you one other thing. Here in the edit fluids area, we can go in and we can see the different AFT standard fluids. If you've created a custom fluid, you can see that in this list as well. Select any fluid, and you can go in and you can see the correlations that we use to generate or to calculate the properties for those fluids. And you can just go in and if you have questions about, hey, what's the specific heat? How's the specific heat calculated for Freon 12? You just have to select that and you can see the curve. We also have some helpful information and the exact coefficients that we're using to calculate those properties here as well. You can see all of that in the library manager and add in your own fluids if you would like. All right, so make sure I covered everything there. Yeah, I think that just about covers Library Manager. I know as I've been using Library Manager in Arrow 9 and then I go back and I start using Arrow 8 and I'm using databases, man, I sure miss the Library Manager because it's much more intuitive, it's much more user-friendly to use to apply your libraries to your model and to kind of edit things and move things around than it was using databases. Databases was complex, it was kind of weird, the user interface wasn't super friendly. Libraries and Library Manager, huge overhaul that replaces that, a lot of improvement there, so check that out. So those are some of the major changes that we've made. I want to cover a few more minor changes. How are we doing on time? Okay. So some of the other changes, or I shouldn't say changes, more improvements and the new features that we've added to Arrow 9, same as Parent from Workspace. To talk about this one, I want to talk about the Scenario Manager just for a little bit. Scenario Manager, if you're not aware, it's a powerful way for you to build maybe step out cases for your model. If you want to model different design configurations, use the Scenario Manager to make little tweaks to your model. The way that this works is we have parent scenarios and child scenarios. So base scenario is a parent scenario. The child scenarios of the base scenario is this 1250 standard cubic feet per minute scenario, as well as this 1330. Those are the child scenarios of the base scenario. Then we have adiabatic 80%, 60% scenarios are the child scenarios of the 1250 parent scenario. And why this is important is any change that you make to a parent scenario will be applied and will be cascaded down to the child scenarios. So let's say you're going in and you want to maybe make a change to your system. You say, this junction, I want the elevation to be not 0, but I want it to be 10. Since I'm in the base scenario and I make this change, that change of the new junction elevation will be applied to every scenario that is the child of that scenario, granted that no other changes have been made to that particular field. So if I go into any of these other scenarios and open up junction J8 and look at that elevation, I should see an elevation of 10 feet because that change has been cascaded down to the parents. So let me just change this back real quick to 0 for our purposes. But if you're like me, sometimes you're in the wrong scenario and you make a change and you don't realize it. So let's say I'm in this 80% efficient scenario and I go in and I change this assigned pressure to, it was 0 PSIG, now it's 100. I click OK, I make a few other changes. I lose the ability to undo that action and I think, oh no, I need to now go in and apply the data that was in the parent scenario to this child, but now because I've changed it, it's disconnected. Like, what do? We've made it very easy for you to apply the parent input information and connect the child back up to the parent. So all you have to do, and this is the change that I made, you'll see this should be 100 PSIG. If I select that junction on the workspace and go over here to the edit menu, down here, there's this new option set called Make Selection Same as Parent. Just as the name applies, it will look at the parent information for the junction that I have selected and then write over the input information that I have in this scenario with the parent information. So I'll select all selected objects. I only have one. I'll click that. It says, are you sure you want to make this change? Yes. And now, because the pressure of J13 in the parent scenario should have been 0 PSIG, I now look at J13 and I now see that new 0 PSIG now applied, effectively making that parent input information take effect for this. So now you can do that direct from the workspace. You can select entire sections, both pipes and junctions, and do the same thing. Say, I want to make these selections the same as the parent. Quick and easy way to be able to fix something, maybe if you made a mistake or if you're trying to make some change. So that's the same as parent from workspace feature. Another fun new feature is the ability to search notes and select special. So let's say we go in to a pipe. If you're not aware, there's this note section. I know not a lot of people might not be aware of it or use it a lot. When I was a user, I didn't use this this tab a lot, but it's very useful to be able to kind of save information. Maybe you want to save some information about where this particular pipe is located, maybe some engineering assumptions that went into defining this pipe. You can go in here, type in whatever, and it will save that to the pipe for your reference later. So let's say, we want to go in here and we want to make a change to this pipe. We can type in whatever again, and then save that. And now that is saved to the pipe. If I want to go in and see kind of what I wrote about that, just for personal notes. This doesn't affect anything as far as the solver or engineering calculations that are performed. It's just for your own personal notes to make sure, you're staying organized, you know what's happening. So this new feature allows you to select special, where it searches into that notes field for every pipe and junction and select those pipes and junctions based on what you have specified. Might be easier to show you. In the edit menu, we have this select special. This isn't new, this has always been here. This is a powerful way to go in and select certain parts of your model based on maybe pipe input properties, or select what's closed in the model and select only those pipes or only those junctions. We added in this notes section. So we can go in here and say, okay, I want to select based on notes, where this selects objects based on the text that I enter. So if I say, I want to select all the pipes that have the word whatever in the note, I just type in that word, click select pipes, and there you see it selected pipe 7 and pipe 12, which are the two pipes that you just saw me go in and select. This is really useful if you want to select only certain pipes for maybe certain areas of the model, or you want to select pipes based on a particular note that you've added in. This makes it very easy to go in. If I click OK, you'll see now those two pipes are selected red. Where I think that this is particularly helpful is in the global edit. So this isn't a new feature with Arrow 9, but if you're unaware, global edit is an easy way to go in and make a change to all pipes that you have selected. If you want to say, I want to change all my pipe sizes from 10-inch to 12-inch, you don't have to go into every pipe and change it from 10-inch to 12-inch. Use the global pipe edit to make that change, where you can select the pipes you want to change, then go in and specify what you want to be applied in that pipe, and then apply that. So this special select special can be used in this global pipe edit, where you can go in, search notes, and say, okay, I want to change all the pipes that have the word whatever in their notes. Click OK, and then go in and make whatever change that I want and only apply it to those selected pipes. I can do that as well. It's a powerful way to quickly select those pipes and then use it. All right, let's go to another new feature called silent batch run. If you've used batch run before, you'll know it's a really helpful way to run a lot of scenarios at one time. You can find that on the file menu. Now, this model doesn't have a lot of scenarios, but I've seen plenty of models that have 100 or more scenarios. And if you want to go through and run every single one, it is a very time-consuming and tedious process to go in, load each scenario, click the run button, wait for it to converge, and then switch to the next scenario and repeat. So with the batch run feature, you can go in and say, I want to run all of my scenarios. You go to select scenarios, select all, and then when I click start run, it will run the first scenario. Once it converges, it will move on to the next scenario. And then once it converges, just keep moving down the list. So you can go in, you can say, well, I have 100 scenarios I want to run. I want to do something else. Use a batch run. Run all those scenarios. Now, if you've used this in before, you might know that every time Arrow would complete running a particular scenario and load the next scenario, if you're working in something else, Arrow would bring itself to the front of your computer, to the front window, and then kind of interrupt what you're doing. When I was doing this, this was very annoying because the whole point of batch run is for me to be able to be doing other work. So it was really kind of interruptive whenever Arrow would then bring itself to the front. So we added in this feature to make it just run in the background. And all you have to do is select this run batch and background checkbox. You click that, and then I can say start run, and it will start running all my scenarios. I can go in and I can be checking email, I can be doing other things, I can be working in Excel, and every time Arrow switches to a new scenario, it's not gonna jump out and be in front and interrupt what you're doing. It's just gonna run silently all in the background. And then once it's done, you'll see in a second, it will bring up the batch run warnings and design alerts kind of summary window, and I'll show you that here. Okay, so this batch run status. So this would appear before, however, in Arrow 9, we've added a few new things to this particular window. What we've added is the ability to see the number of warnings and design alert violations that each scenario has. So we can scroll down and see, okay, I don't have any warnings, any design alerts for any of these scenarios, but maybe in the past, if you've used batch run, you run all 100 scenarios and you get to the end and you say, well, which ones have warnings, which ones have design alert violations? It's not immediately clear. You have to go into every single scenario to check that. Not anymore. Now you can quickly see that from this batch run status because we added in this line for each scenario that tells you the number of warnings and the number of design alerts. You can copy this to a file so you can save it, so you can then close it and go in and investigate what are these cautions, what are these warnings that I'm seeing, and you can use that as a reference there. Last thing I want to show you is just a small little feature that we added to the solution progress window. You'll see this blue text we added in. You won't see it here because I don't have a control valve, but we added in a line that will appear if the special condition state changed for a particular like a control valve. So for instance, if you're not familiar with that, let's say you have a control valve in your model that's not able to control to its set point, and you have it set to when it loses control, it's just going to open up wide. When the arrow is running through its solver and it realizes that a control valve can't control to its set point, it will then change the state of that control valve and say, okay, well now you're open all the way, and then it will actually run the entire model over again because that state has changed, that control valve is no longer changing. It needs to run through all the calculations again. Sometimes this could lead to really long run times, especially if you have a lot of control valves, because it might be going through and one control valve can't control, it has to start the whole thing over, and it goes through again, another control valve can't control. It starts over again, and so it was not immediately clear that this was happening when you're just looking at the solution progress, that you're having control valves, that the states are changing, and that's why you're having a very long runtime. Now we'll show that here in this blue text. It will say, hey, this particular control valve, this junction, it's not able to control. We're setting it to its, either its closed state or its open state based on what you have set it as. And now we're running the calculations over again, just to kind of keep you informed of what's going on in the solution progress, so you don't think, oh, Arrow's not converging, what's going on? You know kind of what's happening. You know, hey, this is normal. Things are progressing. It's just taking a little bit of time because some special condition states are changing. So you can see that from the solution progress window. All right, I think that just about wraps up these new features. Just want to close out and say, this has been a webinar over the new features in AFT Arrow 9. I want to say thank you for taking the time to tune in. I hope you learned something, and I hope you learned something that was valuable and useful to you, a tool that you can use as you go in and as you're modeling your compressed gas systems. If you have any questions or if you want to learn more, please reach out to us at support@aft.com. You can also give us a call at 719-686-1000. If you want to talk to a person, please let us know if you have any questions, or if you want to get a quote on a license for Arrow 9, please reach out to us. We have some great people here who can answer your questions and help you out. Again, thank you for tuning in. I hope you have a great rest of your day, and I will see you next time.